the video. I'm so sorry. So what we're doing right now, everybody, is we're looking at an area of mathematics called combinatorics. Can you guys say combinatorics?
Combinatorics.
Now, combinatorics means the study of counting. It's used in logic. It's used in the physical world we call physics. It's used in the biological world, biology, and it's used in computer science. So combinatorics is a really important area of mathematics. So when I say, Sarah, 1 plus 2 plus 3, we know it's the same as 2 plus 1 plus 3, but the order of things make our counting easier. Now my question is this: how many permutations could we find for the numbers 1, 2, and 3? And I'd like you to write them down. So write down the numbers 1, 2, 3, and then write any other ways, permutations.
Wait, are we writing all of this?
You're writing any way to make 1, 2, and 3 in 3
We kind of did this before.
In 3 what? Sorry?
You only have 3 spaces.
Good.
You only have 3 spaces.
Yes.
And you have to write them all down. So for instance, 1, 2, and 3 is different from 2, 3.
That's okay because now there's a 2 there.
So I have to write all the combinations?
Yes. No, all the permutations. Because
Permutation.
1, 2, 3 is the only combination, but there are many more permutations. And I also have a few people with their hand up, which is great.
Wait, I'm sorry. Wait, I'm still kind of confused what a permutation is.
For instance, Bayram, do you agree that 1, 2, 3 is one way to make 6?
Yes.
So is 2, I'm sorry, so is 3, 2, 1. But I want all the different permutations, not
So-
just 2 of them,
There.
To make 6?
to make the number 6 with
Out
the
of 1, 2,
numbers
3.
1, 2, and 3. And I'm going to ask for Tess to tell us first
No.
how many. How many, Tess?
Yeah. Okay. So how many?
4.
Say again, Tess.
4.
4 is a great guess. Hayden?
6.
5.
5. Excellent, excellent, excellent choice. I'm going to go with Gabby.
6.
6. I have a 4. I have a 5. I have a 6. Now, who can
9.
prove it?
6.
Wait, Bayram, what did you have? Bayram?
9.
9. I have a 4, a 6, and a 9. How about you, Mark?
6.
6. How about you, Sarah?
I'm still working on them a little bit. So far for now, I have 3.
You have 3.
Oh, never mind. It's 6. Sorry, I changed my
Jonah,
mind.
what about you?
Can I change my mind, Mr. Greener?
Of course you can, my friend.
6. I think it's 6.
And Jonah? Jonah, you have raised your hand. I am calling on you.
You already took my hand. Wow.
And permutations, I have not heard from, God, who am I? I am hearing but not seeing. Penny, I haven't heard from you. William, I haven't heard from you yet. How many do you think?
6.
6. Now, does anybody have a proof? Does anybody have a way to prove that 6 is the answer? Cameron, I want to hear from you, buddy.
So I start off with 1, 2, 3. Then 1, 3, 2.
By the way, guys, before he moves on, this is the exact way a combinatoric mathematician would do his counting. Keep going, Cameron.
Then I did 2, 1, 3.
And guys, do you notice how the 1 and 3 are in order? But we started with a 2 instead of the 1. Now, Cameron, I'm going to let somebody else continue from there, if they follow the same pattern. And I want to see, let's go with Tess on this one.
Then 2, 3, 1.
Oh, that's beautiful. Olivia, do you have another one? And keep yourself unmuted, everybody. Keep yourself unmuted so you can answer when you got it. Olivia?
1, 2.
3, 1, 2, and finally Hayden.
1, 3, 2.
1, 3, 2. Hayden was all the way up here. If you follow the Hayden, follow the pattern. 1, 1, 2, 2.
3, 2, 1.
There you go. Follow the pattern. And Will. Go, Will. You raised your hand, Will. A little bit louder, my friend.
He took mine.
Oh, okay. Well, you know what? When somebody else says your answer, you go like this to say, I agree. I agree. It's great when somebody thinks like us. Okay. So copying somebody or taking somebody else's idea is the greatest form of flattery. It's also trademark infringement sometimes. But in any way, let's have some fun. I want to talk about one more word. The word is factorial. Can anybody say the word factorial?
Factorial.
Now,
Factorial.
might it have been easier if we know that we only have 3 different numbers, A, B, and C, and we know that we're going to have 3 spots. All you have to do is put a 3 and an exclamation point. Everybody do that. Put a 3 and an exclamation point. Now, 3 factorial is the way combinatoric mathematicians do this calculation. They do not lay out all the options because that takes a long time, especially when the numbers get big. All they have to do is 3 times 2 times 1. Who can tell me the product of 3 times 2 times 1? On 3, 1, 2, 3.
6.
6.
And guess
6.
what? You just answered the question. So now let me throw out another question. What if you had 4 boxes and you were asked to create the number 10? What is the only combination that we could use? And then we're going to figure out the number of permutations. So I have Mark.
1, 2, 3, 4.
1, 2, 3, and 4. Does anybody agree with that? 1 plus 2 plus 3 plus 4. I love it. Now, how many different permutations? How many permutations? Do not call it out. Write it down. You may want to start with
Wait, where are we writing this down?
on a piece of paper, Barham, or on your desk, or on the back of your hand, but you should use paper. That's my favorite. That's my favorite.
Oh, I thought we were supposed to be writing this on the packet, so I've been writing on the packet. Is that okay?
Oh, it's totally awesome. That packet is yours. It's your property. You write it on that packet, you're going to win. I just say when you're writing something down, it doesn't matter. All right. Now, 4 factorial. Who was able to do? Uh-oh, somebody's talking there. I'm going to mute them. I think I got it.
Wait,
4
are we writing this
times
down on our
3
page 1? I'm
2
confused.
times 1. Yes, Barum, question.
Are you writing this down on page 1?
Barum, some people are writing it on page 1.
Something
Some people are writing it on a blank piece of paper. You get to choose. It is totally your choice. Now, how many of you were able to find the product of 4 times 3 times 2 times 1? Raise your hand. I'm going to go with Gabby, Kelsey, Cameron, Mark, Will, Sunyi. Everybody say it on 3. 1, 2, 3.
24.
Now, that sounds like a lot. It sounds like there's too many. Guess what? Blank piece of paper. Everybody go to a blank.
So
Write
times
the numbers
4 times 3.
1, 2,
4,
3, and 4. And I want you to write out all 24 permutations. And I'm just going to give you a little push. The second one I would do using combinatorics is 1, 2, 4, 3. And then I'm going to give you one more little push, and that's it. So right now, I've given you 2.5 permutations. Your job is to prove that 24
That's gonna be hard.
is correct. And if you get stuck, raise your hand and ask me a good question. Because you know how some people stay alive with food? I stay alive with good questions. So you have to feed me with good questions. Cameron, can you feed me with a good question?
Well, mine's more of like an answer. So once you really figure out how many 1 facts there are, you can figure out the answer to the problem.
Ah, yeah, don't give it away just yet, but I want to see you write out all 24. And I also want your hand to feel like it's going to fall off a little bit. So you know you should always use factorials and combinatorics rather than writing out every single solution, especially when we get into the hundreds, thousands, 10,000s, and 100,000s. Because that could take us years and cost millions of lives. And we don't want that to happen.
This is feeling like a lot. I feel like I've already written 24, but then I realized like I've only written like half.
Oh, good. 12 is good, buddy. And by the way, everybody is going to get to participate when we write these down. Oh, and Jack, I can't see you. I don't know why. Oh, yeah, there you are. There you are. Excellent. And Olivia, okay, good. Gabby, I have Penny. There he is. So how many of you have half of the 24? How many of you have at least 12?
I
Cool.
have more, I think.
And let's say that you have your first 12, do all of them start with a 1 and a 2? They do? Good. Good, good, good. Who can give me the
I finished, I
first,
think.
who can give
I
me the
finished.
first six really fast? Bayram, first six, go.
1, 2, 3, 4, 1, 2, 4, 3, 1, 2, 2, 4, 1, 3,
Whoa,
1,
whoa,
3, 4,
whoa,
2,
a
1, 4,
little,
2,
you know what,
1, 2, 3,
Bayram,
1, 4, 3.
I did say fast, and you are fast, but so everybody can hear it.
Okay.
1, 3,
1, 2, 3, 4. 1, 2, 4, 3. 1, 3, 2, 4. 1, 3, 4, 2. 1, 4,
yeah.
2, 3.
1, 4, 2,
2,
3.
3. 1, 4, 3, 2. And I finished, by the way, just saying.
And that's it. Now, guys, the beauty of the work that Bayram just did is he really gets to copy down the next one. Tess?
I did 2, 1, 3, 4. 2, 1, 4, 3. 2, 4, 3, 1.
2,
2, 2, 3.
2, 3.
4.
Well, I would
One.
do 1. Remember, 1, you want to do them in order if you can, right? 1, 4, and then 2, 3,
2, 3, 4, 1.
and then 2 more.
2, 4, 1, 3.
Awesome.
2, 4, 3, 1.
Wow, that was so cool. Okay, I want to go to dual page here, so somebody else can give me the next group. Who wants to do that? Sarah, go for it, Sarah. Okay, or I don't hear Sarah, so Kelsey maybe?
Oh, sorry, I was just muted, but I said it.
Okay, go ahead, honey.
Okay, 3, 4, 1, 2.
3, 4,
1, 2.
2.
3, 4, 2, 1. 3, 2, 1, 4. 3, 2, 4, 1.
Beautiful.
3, 1, 2, 4. 3, 1, 4, 2.
Amazing, amazing. Kelsey, can you give me the last 6, please?
4, 1, 2, 3. 4, 1, 3, 2. 4, 2, 3, 1. 4, 2, 3, 1.
Good. Keep going.
4, 3, 2, 1.
And I always go in order. And 4.
2.
Wow. Unbelievable. Guys, give yourselves a round of applause. Now, big question. This is the big question. What if we're doing a kakuru that has a 9 by 1 and the sum, well, all the numbers would have to be included. And the sum, who knows what the sum, don't say it out loud, what the sum would have to be. And Gabby, go. Gabby, you're probably muted.
I didn't raise my hand.
Oh, I thought you did. I saw a big hand go up. Anybody else know the sum of 1 plus 2? Hayden?
Actually, no, I don't.
Okay, Mark.
45.
Wait a minute. Do you mean to tell me that 1 plus 9 is 10, and 2 plus 8 is 10, and 3 plus 7 is 10, and 4 plus 6 is 10, and we have 4 10s and a 5, and it makes?
45.
45.
Wow. Now, who knows what happens if we do 9 factorial? And by the way, I am not going to ask you to do this right now. It would take a little bit too long. But if you did 9 times 8 times 7 times 6 times 5 times 24. What? Kramer, why 24? Why did I just do that? Who can tell me why I just did 24? Cameron?
I think you already did the 1, 2, 3, and 4.
Guys, didn't we already do 4 times 3 times 2 times 1? 4 factorial is 24. Therefore, guys, I will tell you, this number is pretty big, and you would probably be as old as Mr. Kramer if you wrote down all of the permutations. No, I mean it. You would be 58 years old before you would be done. Do you want to get started?
No.
Remember, guys, there's only 362,880 ways to write them down. Everybody is allowed to give a little scream, a little scream. Ah, don't do it. Okay. Now, everybody go, phew. I am so glad Mr. Kramer is not going to have us do every single one. Now, let's look at a little chart. I created a chart on page 3 where I look at all the permutations of 2 factorial, 3 factorial, all the way to 9 factorial. And for those of you who love algebra, you can actually think of it as a number n, any number n, factorial, which would be that number, like 9, times the number before it, n minus 1, like 8, and then times the number before it, n minus 2, which would be 7, until you went all the way down to the number 1. But that will come later. It is so much fun to think of all the different permutations. Now, in a future lesson, we are going to use what's called the fundamental counting principle, which is another area of combinatorics, to figure out, for instance, the number of ways we could order dinner at a restaurant, the number of ways we could choose to put our clothes on in the morning. So combinatorics is really exciting. Now, I have actually chosen in my own life to make my life more simple. So for instance, where I used to have more choices, I have tried to reduce the number of choices I have. And we're going to actually be able to use mathematics to reduce choice. Because do you know that choice makes us a little bit anxious? So I'm trying to take choice out and add in fun mathematics. Now let's get started with the next piece of our lesson, which is this. Everybody go to page 4, please. On page 4, you know that last week we had sets of 2 were the easiest ones to solve. But we only wanted sets of 2 that had a clue of 3, 4, 16, or 17. those were the only sets of two that had only two different solutions. So for instance, do you remember that Mark told us that 17 could be 8 plus 9 or 9 plus 8? What about the number 16, guys? Say it out loud.
7 plus
9
9
plus
plus
7.
Now, this week, we are searching for the most combinations, the fewest restrictions on a Kakuru board. Now, you would never do that because that would not be good Kakuru etiquette. It would be too hard. But I'm asking you, from the numbers 5 to 15, don't say it out loud. Which number or numbers do you think have the most combinations? Permutations are even crazier, but who thinks they can find the most combinations? Which numbers? And don't say it out loud yet. I want you to make a conjecture. A conjecture is an educated guess. And that's what I'm looking for. So why don't I ask Sunyi, I haven't heard from you today. I'd like to hear your thoughts on which one, and then Penny. And everybody should unmute themselves so they don't have to hit a button when they want to talk. Okay, go ahead, Sunyi.
What do you mean?
I'm looking for a number from 5 to 15 that would have the most different combinations for a clue of that number. And so for instance, let's hear from Penny. Penny, what do you think?
And because you could do 1 and 9, 8 and 2.
Wait, what number, what clue have you chosen, honey? Did you say 10?
Yeah.
Okay, hold on. If Penny chose 10, Penny, can you go through the different combinations, please?
2, 8, 9 and 1, 8 and 2.
I'm sorry, your sound's not coming through. It's
7 and 3.
good.
6 4. 5 and 5.
But are we allowed to do 5 and 5 on Kakuru?
No.
So there are 4 combinations and how many permutations? Who can tell me how many permutations? On 3, 1, 2, 3, go.
8.
Right, because
8.
there's also 1 and 9, 2 and 8, 3 and 7, and 4 and 6. Now, who can come up with another number? Sarah, I don't know if you had your hand up or Jack, but is there another number that you think would also have 8 permutations?
13.
Anybody else? What's another number? And I really think Penny do you know where Penny started? The number 10 is actually called the median number. It's the absolute middle number. Penny, you rock. But there are other numbers that have the same number of. Who thinks they've got it? Go ahead, Hayden.
Maybe it's 11 or 12.
Well, it's interesting you said 11 or 12. I would say 11. Tess.
I just have an idea.
Okay, go.
Maybe I was gonna say 11.
Good. But if you say 11, which is one more than the median, then you should also say, come on, guys.
9.
9, which is one less. So everybody right now write down all the different solutions for 11 and all the solutions for 9. Go.
On that page.
Should have 8 for each.
10 and 1, 1 and 10 for 11.
Oh, wait, 1 and 10 doesn't exist because we don't have the number 10. We only have 1 through 9. But Sarah, great question. Remember, I feed off of great questions.
Wait, what?
9 and 2.
That is true, but you write them down, honey. You write them all down. I want everybody writing them down.
So we're trying to make all the ways.
All of the permutations to make 11 with 2 boxes and all the ways to make 9 with 2 boxes.
9 with 11 with 2 and 9 with 2.
That's right. We already did 10 and found 8. Now we're trying to find 8 with each of 11 and 9.
Okay.
So for instance, when Sarah said 9 and 2, that was my first one too. But then of course I would do 2 and 9.
Yeah. But isn't that the only way to make it?
Well,
This is not only
I would do
addition.
3, and then I would do 3 and 8, and then 7 and 4. Keep on going, Bayram.
Oh, I thought. You said only with 2, so I was a bit confused.
You can't do
Well,
one.
two numbers, Bayram. You have.
Oh, I thought you meant with the number 2.
Okay, fair enough. Fair enough. Will, do you have a question, buddy? You were just waving. That's good.
I finished mine.
Mark, you have a question, buddy?
No, but there is 8.
Oh, you found 8 for both groups? How
Yeah.
about you, Jack? Did you find 8 for both groups?
Well, I think for
Yeah, me too. Oh, sorry.
Bayram, don't talk over Jack. Go ahead, Jack.
yeah, I did.
You did? That's great. So, guys, this is very exciting. Now, I want everybody right now to go to page, I'm sorry, wrong page. Go to page 6. Do you guys remember there were 4 numbers that had the fewest, that had the least combinations, the least permutations with 3 digits? Do you remember what those numbers were? And I don't want you looking back to Curl. I want you just looking at page 6. And I'm going to go with Hayden first.
It was 3 and 4 and 16 and 17.
Now that was when you had 2 digits, but this is with 3 digits. You are correct on 2 digits. This is 3 digits. It's a little bit different. And Will, are you raising your hand or no? No? Okay.
Mr.
Mark?
Kramer is 12, one of them?
I'm not really sure. We'll have to figure that out in a second. I don't think it is. Mark?
Ew.
I think 6, 7.
Well, wait. Hold on. Why did you say 6, Mark?
Oh, because you can do 1, 2, and 3. That's
Yeah,
like
guys,
the only
the
way.
3 smallest numbers. And Mark, why did you say 7?
You can do 1, 2, and 4.
Right. Now, Mark, hold on a second. Can anybody now tell me what the other 2 are based on what Mark did with the 2 smallest groups? What about with the largest? Who thinks that they can do the same thing? Penny? Penny,
Ooh, I got it.
we can't hear you yet, Penny.
Next one's 8.
Wait, say again, louder.
I think the next one's 8.
Now, what numbers did you want to use for 8?
1, 2, and 5.
Yes, I agree with that. But can't we also do, anybody have another one for 8?
Wait, I think I found the other one.
Wait, hold on. Couldn't it be 1, 3, and 4 also, Penny?
Yeah.
So 8 actually has more than one combination. And wait, somebody else just raised their hand, but it's not up. Mark, don't wave like that because you got those first two. Baron, did you want to?
Yeah, I think I know what the next one is. The one that has the least combinations. Is it 24?
Ah, it
9, 8, and
is.
7.
Did you say 7, 8, and 9?
Yeah, 9. Well, I said 9, 8, and 7. That was the
All
order I
right,
did.
beautiful, beautiful, beautiful. Now, who has the last one? Somebody else with the last one. Think of what Bayram just did with 24. Think of what Mark, oh, Hayden, can you change your background to non-virtual because it's a little distracting? And who can do the next one based on what Mark did with 6 and 7? Come on, Gabby, you can do this. What do you think, Gabby? And can you unmute yourself, please? Everybody should unmute themselves.
7, 8,
Nona, do you have this one? Isabella, do you have this one? Sarah? What about you, Kelsey? Will? Sunyi? William?
Is it 9?
Well, 9 would have what numbers?
4, 3. Yeah, 24 is
Come on, 4, 3, and?
2.
Yes, but couldn't we also have, what's another one? Like 6,
What about
2, and 1? There
I
are
also got
many. 9 has many.
320?
Gabby, go.
20. Maybe 12.
Well, I think 12 is going to have a plethora of answers. What about you, Tess?
Plethora.
That means a lot. Tess?
20.
It's a plethora.
20 is good, but there's one better than 20. Actually, there's a few better than 20. Bayram.
23.
Of course. Guys, if Mark said 6 and then 7, then 24 and then 23, because tell me, Bayram.
9, 8, 6.
Of course. Those are the only combinations for those 4. Those are the only combinations for those 4. Now, everybody go right now. Everybody go right now to page 8.
Oh, yeah.
Everybody go to page 8. Now, I want you to look at page 8. I've put the numbers 6 and 7 on the left, 23 and 24 on the right, and all the other numbers in between. Now, based on what Penny did, our last exploration, which number do you think has the most combinations and therefore the most permutations? Don't say it out loud. Write it down, circle it. And by the way, there may be more than one number. That's right. There may be more than one number.
Can I say my guess?
Not
my
yet.
estimate?
Not
I
yet.
have no
I
idea.
want, Bayram, not yet.
Number
Because I want
of
everybody thinking about it independently.
Wait, is this 2? Like you're adding 2 numbers, or is this adding 3 numbers?
24 is 3.
We are adding 3.
23 is 3.
Okay.
23 and 24 are both
3. 20. So that's, yeah. So
All right.
that's
So I'm now going to be looking.
24.
Now going to be looking for someone to give me their conjecture. Now, Kelsey, I'd like to hear from you.
Mr. Kramer,
If you have an idea, hold on a second. Kelsey, go for it.
maybe 13 or 14.
Ooh, you are right in that sweet spot. You are right in that sweet spot. And guess what? One of your numbers is correct. Will, what do you think? You had your hand up.
20.
Yeah, 20's good, but it's way close to 23 and 24, which have very few combinations. Kelsey, do you want to amend that? Kelsey, did you have your hand up again, love?
Yeah, I think that
I just messaged you the one I think it is.
Okay, excellent. And Kelsey, I can't really hear you. I think it might be your internet connection. And Gabby, can we hear from you?
Well, 15 is what I think, because you said 13 and 14 were right around that sweet spot. So I was thinking 15 because that's like right next to those two numbers.
Guys, 15 is just like the other one with 10. This is the middle number. It's the median. And so now when Kelsey said 13 and 14, we know that which one of her other numbers is in that sweet spot. Say it out loud.
16.
It's
14.
14
Oh,
and
14.
16. That's right. Now, let's give it a shot. Everybody right now, start with 15. Remember, 3 numbers, and I want you to write all the different combinations. Remember, combinations are not permutations. So you're going to start with one with 3 different numbers. I recommend that you start with the number 1 and the number 9. That's the only push that I'm going to give you. Start with 1 on the left, 9 on the right, find the middle number, and then find all the different combinations where there's no repeat of the same group. And if you have a question, ask the question. Sarah.
So
Go.
we're doing 14, 15, and 16.
Wait, Baron, raise your hand next time like this with your hand like that. And I'm going to call on Sarah first and Baron. Go.
Okay, so do they are we allowed to do like 1, 5, and 9, then like 1, 9, 5, and then like 5, 9, 5?
Right. So Sarah, those are permutations,
Mhm.
but
I'm
1,
not doing
5,
those.
9 is the only combination with a 1, a 5, and a 9. So the
Oh,
next
so just
one
like the
you
different
do-
combinations.
Right. And now, Baron, you had a question, and then Gabby had a question.
So, yeah, so are we doing 14, 15, and 16, or just one?
You're
And I have a
just
second.
doing 15 right now. We're
Oh.
just doing the 15. Excellent.
And also,
Yes, sir.
wait, one more question.
Yes, sir.
Actually, never mind. I think you answered this to Sarah. We're
Excellent.
only doing one of a number, so not doing 195. I mean 195, 159, right?
Right, because you know there are 6 permutations for each group of 3. We've already determined that. Gabby.
Can you do like 5, 5, and 5? Is that allowed?
Remember, these will follow the rules of Kakuro for the time
Oh,
being. So then we will not use 5, 5, and 5. Gabby, another great question. Thank you.
And I had one other question. Can
Yes.
like I combination of 1, 5, and 9, and then do another combination of 4, 5, and 6?
Oh, yeah. 4, 5, 6 would definitely be another one, but that would not be in combinatorics. Combinatorics would say that you would go next with a 1 and then an 8 and then a 6. So you've got to follow a pattern or else you're going to have trouble finding all of the combinations. So
Got it.
I'm just recommending that. You can use any way you want, but combinatorics would say keep an organization. Sarah, yes. Sarah, you had your hand up.
Yeah. I figured out the thing, but I don't know how to keep going because I end up with the same number. I end up with them just flipped.
So after the 1, 6, 8, I would then go with 1, 7, up. Can't go with 7.
Yeah. So then,
And so then
that's what I did.
then I would say, okay, after the 1s, let's start with a 2. 2,
Oh.
9, and 2, 9, and 4. And then 2, 8, and 5. You see that? I'm not going to give you any more. I want you to continue on.
Okay.
That was another great question.
I noticed a pattern, Mr. Kramer.
Awesome. Now, hold on one second. I have another question from Gabby. Go for it.
I didn't mean to raise my hand.
Oh, no problem. Yeah, Baron, can you share?
Okay, so the pattern I noticed is what you do first. There are steps, okay? First step is, of course, right now we passed the 2 2s, right? So now let's go on to 3. Can we go on to 3?
No. Because
Well-
there's one more 2.
Oh, there is? Oh, well, then I
Because
missed it.
Did you try 2, 7?
I did, well, here's, I did 2, 7, 6.
Yes. Now we're ready. Now we're ready to go on to the 3s, Baron.
Which one am I missing? Oh, I haven't done 2, 4, 9. 2, 4, 9. Okay, so
And
the
that would have
pattern I
been,
noticed
that would have been the first one. Yes.
is that it kind of messes up. But if the first 2 2s, it still goes on. So in the second column, the middle column,
Yes.
yes, the number is expanding is by 1. It's going up by 1 every time. And then on the right column, the number is going down by 1 each time. So instead of having to calculate, once you can just do that pattern. You go down on one column and you go up on the other one.
Now,
'Cause,
hold on. Can I ask Sun Yi, did you have the last combinations? Because I want to check out Baron's idea. Because I thought you had your hand up. Does anybody? Go ahead, Sun Yi.
The last combinations are the 3, 4, 8.
Okay, so and what's interesting is you can't use a 9 because that would be a repeat of a 3. So 3, 4, 8, beautiful.
3,
And then we'll
5,
go-
7.
Wait, Baron, let him speak. Go ahead, Sun Yi.
3, 5, 7.
3, 5, 7.
We can't do 3, 6, 6, so I usually skip the doubles.
Right, and Kelsey, can you give us the last one? Go, Kelsey.
9.
Yeah, I think your internet connection is bad because we can't hear you. Can anybody tell us the last one? Go ahead, William. Unmute yourself and tell us.
Our last one was 429.
No, it's
Um,
429.
429. And 429 is right over here, my friend. I agree it's going to start with a 4, but it's going to be in ascending order. And in fact, I know that Gabby has it because she said it earlier. Come on, guys. 4. Go ahead, Sarah.
9.
For what?
419.
419. 419 is true. And 4, 1, and 9. Now, why did we miss that one? Yeah, does that make 15?
That makes 14.
So that makes 14. And go ahead, Will.
4, 5, 6.
Yes. Gabby, remember when you said 4, 5, 6 earlier? Yes, guys, there are 8. And what I would like to understand right now is this, guys. It's very important. Do you realize that each one of these combinations have 6 permutations? Who knows what 8 times 6 is? Go.
These lines has 6.
48.
48.
And guess what, guys? The number 15 would literally have 48 different ways to put 50 numbers in those boxes. Oh my God. Drop the mic. Drop the mic. Unbelievable. Now, your job this week is to think of things like this. What if we looked at sets of 4 numbers? We know that 10, 11, 29, and 30 are the absolute easiest. So somewhere in that sweet spot is the absolute worst in that has the most permutations. Your job is to find it. So everybody say goodbye to their friends. Say, we are going to be
Bye.
Bye, combinatorics. Bye, guys.
Thank you.
Bye, 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 bye.